For page 16 of the course notes, we're going to use another handout. So I'm at the course content here, and it's going to go into lectures and to handouts, and I've just added this, the Dining Phils handout, or Dining Philosophers. Okay, so I'll start at the top here. We've got some of our usual headers, SimSys OS2 for the real-time OS function calls, LPC17XX for anything related to the processor, which might not be needed in this case. A standard bool, so I can do while true, and standard lib. This gives us the rand function. It's a standard library call, and it returns a random unsized integer between 0 and unsigned int max, which is on a 32-bit processor, that would be 2 to the 32 minus 1. And I parameterize this so that you could use different number of philosophers, but it's normally 5. So I've created a macro number of philosophers, set it to 5. And I've got two arrays here. So these are the philosopher IDs. So I'm just going to fill it with the number 0, 1, 2, 3, 4, but I can use that to pass the philosopher ID into the philosopher task. They're all going to run the same code, so they need a way to know their ID. And then, well, these are the forks, as the name says, so I don't think I need to add to that, and we need the same number, so 5. So the philosopher function is found below the main, but I want to look at the main first. And I've squeezed this in a little bit, the main, just so that there's more room in the philosopher task to add some handwritten code. So we initialize the kernel, and then we're going to loop 5 times, and each time we're going to set the entry in the ID array to the index of it. So 0 will be 0, 1 will be 1, and so on. And we will initialize the fork, or we'll create the mutex for each of the forks. So we create a new mutex and remember it in fork I. And here we're creating one of the 5 philosophers. So we pass it the function, so you'll notice it's always passed the same function. But what's different is this line right here. This is the parameter, or the argument that's passed to the philosopher function. This could also be written as fill ID plus I without the ampersand and the square brackets, and using pointer arithmetic, that would give you the same result. So that's a fill underscore ID. So that's how we're passing in the philosopher number, and the null at the end there is the default attributes. So once we've got all the forks initialized and the threads created, we will start the scheduler, and we should not get to the for loop here. Okay, so here's the philosopher task. It does use its argument here, and I've called it IDP for ID pointer, and we know from the code in main that we're passing in a pointer to a uint32 type. So we cast IDP to an uint32 type pointer and then dereference it, and that gives us the ID number. So this line gets the philosopher ID number, and that'll be a number between 0 and 4. And we have, as usual, an infinite loop, and these are the actions that they take. So they're going to think for a while. They will not think for 0 time units. It will be a number greater than 0 up to and including 5. So I'm using that range notation. The round bracket means not including, square bracket means including, and that's seconds. So we take the tick frequency, multiply it by 5, so that's the number of ticks per second, multiply by 5, and we mod the value returned by rand with that number, and that will give us a random number in the range of 0 to 4, and 0 to whatever 5 seconds is in ticks, minus 1. Then we add 1 to all of that, and that gives us a number from 1 tick to whatever number ticks 5 seconds is. So then we delay here, and after delaying, this is the part that we're going to be filling in here. We need to tell the philosopher how to pick up the forks, and then there will be another random delay down here. So we choose another random interval, we delay, and then the philosopher will put down the forks. And probably the simplest approach is each philosopher will pick up the fork to their right and then the fork to their left. So that would look like this. We can give the fork number a name, so let's call it first, and that will be equal to their ID number. And the second fork to pick up will be ID plus 1, and that's the case for philosophers 0 to 3. For philosopher 4, it needs to pick up fork 0. So we can make that happen by taking ID plus 1 modulus 5, or in this case I could use nfill to make it more generic. So we've determined the order of the forks that we're going to pick up, and so now we can do this. OS mutex acquire, and the fork mutexes are an array called fork, so we need to give it the index there, and we're going to wait until we get it. So OS wait forever, so no timeout. And then the same to pick up the second. So OS mutex acquire fork second, OS wait forever. So that will pick up the fork to their right and then the fork to their left, and then we'll simulate eating by delaying for some random number of ticks between 0 and 5 seconds. And then when the philosopher is done, it needs to put down the fork. So it needs to release the mutex so that another philosopher task can acquire that mutex. So it's simply two statements here. OS mutex release, and the order here really doesn't matter. Let's make it, I think I did this before where I reverse the order in which they were required. So fork second, when it's releasing the mutexes, it can't get blocked doing that as long as it's got both forks already, and it will if it's gotten to this point. So I could have done first if I'd wanted, and that would have been fine too. So I'm going to look at the solution a little bit on the next page. I think I forgot to actually number this up at the top here. So this was page 16.